Hello, we are back live with our final episode of the Open Research Series. This one on parallel execution, and we got as a guest our dear friend, Mr. Llama, the Zen Llama, otherwise known as Kevin G. Welcome back, sir. Good to see the friendly face again, and thank you for
Yeah,
joining us.
always good to be here. It's always fun to be here.
All right. Let's kick it off with just setting the stage on parallel execution. Actually on the status quo, and then we'll segue that into parallel execution. So, like Zen, if you can orient us, what is the status quo for just like execution in a blockchain context? What are some of the problems, and where does parallel execution fit in?
Yeah. At a high level, this can actually be like really succinctly understood through the lens of like computers, right? In the back in the day, if you remember, like in the early '90s, it was like the Pentium processor, and they were talking about like, oh my God, like we now have like the Core 2 Duo. I remember that being like a big thing when I was young, and that was like this like moment when it took like computer processors and went from like single threaded execution to multi-threaded execution. And so what that means is like generally speaking, like computers as they existed back in the day, and this is the same case for VMs in the early days with blockchains, only had like one lane of execution, one thread is what they were called on the physical chip. Um, and so what that means is like you can only execute instructions sequentially. In serial is another word for that. But essentially, for any computer program, like the most you could do is basically like step through it line by line and execute things. Um, when multi-core systems came about, there was this concept of like, oh wow, now we have like two swim lanes, so we can technically have like two processes going on at once, right? Um, in normal computer systems, this gets like way more complicated than what we see in blockchains. But in the blockchain um, like space, when we're talking about parallel execution, we're really talking about it from the perspective of a transaction and the fact that you can run multiple transactions at once. And so, analogous to programs in normal computers, where if you had a multi-threaded computer, you could run like, Word aside from, maybe Zoom. Um, Now, in a blockchain context, we're moving to this realm where in multi-threaded VMs, where you can process multiple transactions at once. Um, and so, yeah, in that sense, you're essentially running multiple programs at once. Yeah, hopefully that
So
answered the question.
no. It did set the stage, and I
Mm,
like how you have like the broader kind of distributed systems and like embedded systems background, and you can kind of like contextualize it like that. Where does parallel execution come in? Actually, you know what? Let's talk more broadly than blockchain for a second.
yeah.
Um, where has parallel execution been like most important, like beyond the blockchain space?
Yeah, so there's a couple flavors of parallel execution. Um, I think the most easy one to reason about is the one I just talked about, where you just have like two workers, right? And so in modern day computers, like um, essentially they have a bunch of threads and they're split up between, running the graphics components, and then maybe some of them running your browser. There's like an intelligent schedule that basically like kicks off where any of these workers should be working at a given time. But it introduced like the modern age of like multi application systems, right? For the most part. So if you remember on our old like smartphones, we used to not be able to like switch apps, right? And that was really because like there was like a limited number of threads and they couldn't like process everything um, uh, like together, right? And so now, like in the multi-threaded world, we see where we can like switch between apps. They're updating in the background. They're doing stuff like that. That's all because of parallel execution. Um, Now, there's a different flavor that's been very powerful in like more compute heavy landscapes. And sometimes, like in the blockchain world, these get confused, especially since Solana initially wanted to do this, and I think they were the first parallel execution environment. And so sometimes it bleeds into blockchain a little bit, but there's also GPU style parallelization, which is called SIMD. And that's single instruction, multiple data, is what it stands for. And so that type of parallelization is you're actually doing the same task, but you're doing it across different data in parallel. Um, and so that's very used for like dense compute things. It's like the reason AI has progressed. It's like why we have neural nets. It's like all this stuff. Um, and it's because it's like very good at doing the same calculation across like a lot of data at once. Um, and so there's kind of two types of parallelization. Both are the same concept, right? You're just adding more lanes. One of them is like multitasking, and the other one is like doing the same task against multiple data. Both are useful in the context of blockchains, but I think mostly the way most blockchains work today is in the multitasking thing, where each one of those tasks is a transaction. So,
Yeah. The context that I had even before I got into the crypto space is like the two different flavors of that for model training, where it's like either you're clipping up the
mm,
data or you're clipping up the model. And like for like hyperparameter tuning, you're like trying the same model a bunch of times with the same data, or like vice versa. You have a big fat model and you just need to like chop that up. And so like that, I think that kind of maps to the two that you
yeah,
outlined. And
exactly.
then
Yeah.
it makes a lot of sense. Okay, so like it sounds really good, right? Like you think of like a bunch of applications that are running in parallel. Everyone's aware of like the contention that existed on Ethereum first, and then like EVM L2s, etc. So it sounds great. It's like you can parallelize everything. Are there any not super intuitive limitations where you're like, all right, well, not quite all these apps can actually benefit from that, or any other types of like edge cases that people might overlook?
Yeah. So the biggest one is frankly just like um, if two things need to read or write from the same data, if two things need to change the same piece of data, like they have to be serialized. No matter how parallel the system is, no matter whether you're on a GPU or on a CPU, whether you're on a blockchain or some cloud computer, right? If two things want to edit the same piece of memory, they need to be serialized, right? And so in all parallel systems, you run into this problem where if you have two conflicting writes, you have to serialize the access to that data, or if you have a read after a write, because it's non-deterministic as to like what the result will be. Like if you read before you write, you're going to get a different result than if you write before you read. Um, and so in both of those scenarios, you have to basically block parallelization, right? So this creates all sorts of challenges when the data that you're acting on is the same. Now, there's a world in which like you just have completely separate data, and this is where I think some people you see people make arguments for that Ethereum is parallel in the sense that like there's different parallel L2s, right? Um, that's like parallel in the sense that because like the data is parallel, right? Like the L2s of different state, and so they can have a completely different world. And so, in a sense, yes, I guess they're parallel execution environments. Within a single environment, though, you're acting on the same state. Um, and so then you run into these issues of like, okay, well, we're using the same database, we're editing the same state of the world, but we want to do multiple things at once. And so necessarily you run into these issues where if two people are trying to write the same data or read and then write the same data, you have to do sequential processing. It's like you just can't get around it. And so that obviously creates a bunch of scheduling complexity about like what goes first, what goes second, do you have to retry, blah, 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 all that type of stuff. We can get into that more.
Yeah, on that note, people have talked about paralyzing. I mean, I think everyone's aware that like the SVM is paralyzed, and like that's how it was popularized too. And now, of course, with like Monad, which you're working on, and Mega ETH, and there's been some talk about the EVM being paralyzed, and like MoveVM talks about like the movement guys talk a lot about like parallelization. And so I guess like within kind of for parallel execution across these different types of VMs, do they all work kind of the same way? Are there kind of like limitations to one but not the other? Can you kind of highlight some of those differences?
Yeah, so a bit of a clarification, Megaeth is not parallel. They're just single threaded. Um, but yeah, regardless,
Oh, okay.
anyways, yeah. um, uh, they're just like high throughput, single threaded. But I don't know, maybe they'll fork a parallel VM at some point. Um, but yeah, getting back to your initial question, um, there's kind of like two main ways to resolve conflicts, right? Um, wait, sorry, was that your initial question? Sorry, I kind of blanked.
It was just you got parallelized SVM, MoveVM, even parallel EVM work. Like, what are the differences there? How should people think about
Ah,
them?
okay, yeah. And so like the fundamental concept's the same. Like you're trying to run multiple transactions at once. Um, but like I said, there's these caveats about how you resolve conflicts, right? If you don't know anything up front, if they just give you transactions and you have to run them, you have to kind of do what Monad does, which is assume everything's parallel, detect any conflicts, and then resolve them with a re-execution. Okay. Um, the other way would be to have the programmer state up front everything that it's going to touch, and then you do it kind of the opposite way, where you schedule it in the correct order and then you execute, right? So in the former situation that Monad does, we don't have to do the scheduling problem, but we do have to reschedule if there's a conflict. In the other scenario, like a Solana case, you have to specify the state up front, so it's a little heavier on the developer, um, and then they have to do the scheduling problem internally, but then they never have to re-execute. And so that's kind of the trade-off. Both can be fast. It kind of depends on how you do it. If you do the re-execution one that Monad does very naively, it can be slow. If you add in some heuristics around checking things, pre-executing, doing some static code analysis, it can be just as fast as anything else. The one benefit with the way that Monad does it is because we're not requiring developers to state dependencies up front. We don't have something called access lists. And so you'll see this in Ethereum circles too. There's an EIP to provide access lists that we do actually support. They're optional. And then you'll see some EIPs that sometimes try to make access lists mandatory for the EVM. They've floated around here and there in order to get like a parallel EVM. Um, I mean, we personally believe that it's not necessary, in that the most constrained um, resource in a blockchain, anyways, is bandwidth, and access lists actually add more data that you have to send over the network. And so it's actually constraining your bandwidth resources in to maybe increase the execution resources, but I don't know. It's like not that big of a bump, and so you might as well save the bandwidth.
Makes sense. Yeah, the next question I was going to ask was actually about like just the practicalities of
Yeah.
the optimistic approach and just like how much of a burden that actually is. Like it sounds great. It's like okay, you don't have less of a burden on the developer up front. You don't have to state anything. But then like you could tell somebody that it has to re-execute like all the time, and it's in practice really annoying, or maybe it just like rarely happens, and
Yeah,
or it just totally depends. So
there's definitely, if you don't implement it right, like there's definitely a case where it's slower, right? You do have to add in things like, you can't just be like, oh, if they conflict, we'll re-execute, right? I mean,
yeah,
it
yeah.
works, like it'll get through the load, but there are scenarios where like it'll cause a lot of re-executions just from thrashing and stuff. Um, but if you do some like minimal heuristic analysis or even just static analysis of the transactions coming in, you can actually mitigate like a lot of that overhead. Um, and so yes, there's a case in which like it is slower, but there's also like a pretty, like if you're a good engineer and you can put some basic heuristics around like, hey, did this, drain the balance of this account, or does the next one have enough money to pay for these in parallel, even though they both touch the same account? Like you can do some very basic high level heuristics around transaction patterns and like optimize this like much better than like in the blind case.
Got it. Yeah, it makes sense.
Yeah.
So, Dimitri, I wanna pull you in a little bit. like, do you have any thoughts based on like how does the stuff that Zen just outlined map to how we're thinking about potential parallel execution in our blended VM?
Yeah. Yeah. So, in blended execution approach, everything is blended, even parallel execution. We blend like instructions, access to the database. So, for execution environments we have inside, they all operate with the same primitives. And the same we do for all for the parallel execution. So we were compatible with original Ethereum transactions, and we are researching several concepts. The first one is to enable mandatory access lists, because there is an issue why it's not super trivial to enable mandatory access lists, because you can create a contract that always fail mandatory access list check, and it won't be executed anyhow at all. So technically, you can create such contract. That's a good question. Does it make sense to create such contract? The same discussion had around the signature check between, for example, EVM instruction set and, let's say, WebAssembly instruction set before they announced Ethereum object format. So it's quite a good question to argue. Does it really make sense to not support mandatory access list, because they can bring some benefits, especially for Fluent, where we blend Solana execution environment and we support Solana transactions. And by doing this, all execution environments we have inside, they use the same parallelization concept. And no matter what parallelization concept you take, if we go, for example, with block STM, it is automatically applied to all execution environments we have, to Solana, to EVM, to WebAssembly applications as well. If we go with mandatory access lists or strict access lists and do forced parallelization for all transactions, it's automatically applied to all transactions. So Fluent is kind of flexible, because Fluent is an execution platform. It's more like VM abstraction. So, and you can wrap this account abstraction around different technologies. It's possible even to integrate Fluent inside Monet, for example, or Mega ETH, or Go Ethereum, or Rust Ethereum, or, for example, Cosmos SDK. Why not? Because it's literally an execution engine. So that's our take on the parallelization for Fluent.
So you would either have to make the SVM speculative execution parallel speculative execution, or you have to make the EVM access list, but you kind of have to unify, correct?
Yes. So
Yeah.
we use only EVM compatible transactions, and
Yeah.
we do not support SVM transactions right now. And we don't see why it might be necessary. Why do you need to have multiple wallets to access the same state tree? It brings some additional redundancy for users, and it misleads developers a lot. By choosing only one method, it's automatically applied to all execution environments by default.
Yeah, that makes sense.
So when it comes to you touched on this a little bit before, Zen, and how there were certain extra technical things you have to do to like truly realize the promise of parallel execution. What are some of the hardest? Yeah, there we go. So like, what are some of the hardest, technical challenges that you guys had to tackle? We've heard a lot about MonadDB. Can you kind of like walk us through some of those other innovations that people might not think about right away?
Yeah, I mean the biggest one is the database, right? You can kind of think about it like trying to suck water through like a hose versus like a water bottle, right? Or I guess like a better one, the straw versus a water bottle, right? Um, and so like if the amount of water in your mouth is like the execution, right? And how much you can actually intake, like your database is the width of the hole, right? Um, and so like it's only so useful. Like compute is actually the most unconstrained thing in a computer, like in a blockchain environment. It's actually the thing we have the most of is just like running cycles on the core. The thing that we have the least of is bandwidth, and the second thing that we have the least of is state access. So the database, how fast can you read the memory? How fast can you pull up data, historical transaction state, so that you can mutate it with the new transaction and turn it into something else. That is like actually the second most constrained resource in the blockchain, right? And so even if you blow open the constraints of compute with parallel execution, it doesn't actually do much unless you can like feed that with enough data to actually make it useful. And that's where like MonadDB comes into play, right? Really, the whole thing is about like, hey, let's make an asynchronous parallel state access database so that when we have parallel execution, we can actually call up the required data for all those different transactions in parallel as well. And that really is what like actually makes it possible. Parallel execution alone is actually like the easiest. It's like pretty logical. It's been around in the industry for long enough. People understand how to do it. There's well tested algorithms about how to implement it. Whether you do OCC or access lists, they're kind of well understood problems in multiple industries, right? And so that's actually like the least hard thing to do. The much harder thing to do is to actually feed that data in parallel fast enough. And so like one thing they tell you is like never build your own database if you're building a system. And like, yeah, we definitely did that. And so like, yeah, it's like it's very challenging. It's a lot of work. It's probably the thing that has taken the most work with Monad. But the payoff's really big, right? Because you get this system where you can actually call up data in parallel and not have to wait on the database to get you stuff. So
Makes sense. Yeah. I was actually gonna ask, well, I don't know if I was gonna ask it, but I was thinking, I was like, okay, I know you guys have been in DevNet for quite a bit. Like I think everybody knows that you're working on some hard engineering problems. And the first thing that comes to mind is like, is this database as the thing that could be potentially the most challenging, is what I
yeah,
would guess.
yeah. I mean, like testnet soon, sooner than most people probably think. So that's good.
Oh,
Like, yeah, I can't drop any specifics, but um, but yeah, like testnet soon. It's obviously a challenge. I would say like the biggest challenge with any blockchain system is like you kind of get to a point where you realize, okay, the blockchain's done, but there's like so much other stuff to do. um, like even if your blockchain works, like it doesn't mean like all your RPCs are solid. It doesn't mean like everything, all the infra surrounding the blockchain is just like ready to go, right? And so like that's really what takes a while, and that's what DevNet's for, is to get all that stuff worked out.
actually, let's talk about that a little bit. I mean, this is the last episode of this, so we can go off track a little bit. I'm curious, just more broadly, like what are some of those, I guess, surprises that you guys, not surprises, but things that you ran into that you're alluding to there. You mentioned RPCs, but like what are the things you're like, oh damn, I didn't realize how much on the periphery there would actually be. Like what was the most cumbersome, hard, expensive, whatever?
I think like optimizations around state access are probably the biggest ongoing thing. It's kind of like a problem that can be good enough but never perfect, right? You can always do stuff in your caching layers, in the way that you look at state and stuff to like squeeze 1 or 2 more% out of things, right? As far as like speed and like a slightly better algorithm, maybe it performs better under these heuristics, but for these transaction types, it doesn't perform better, right? So there's a bunch of analysis going on and all that stuff. Looking at more challenging blocks on Ethereum history and figuring out, why is it slowing down here versus somewhere else? And then trying to like balance the optimizations of all these like memory caching and like database access parts of the system. Like all that stuff takes forever. And it's like, it's kind of like where you squeeze that 1, 2, 3%, and over time, it becomes significant. Um, there's also like just stuff around like our fee markets are going to have to be different than Ethereum, simply because the block times are different, right? You can't just copy and paste B1559 onto a different block time. Like it's a filter, and it's based on the window size. And so there's stuff around fees that we're still working on. Yeah, and then like the staking system was something that's going to be a little bit later coming. Like the initial blockchain just kind of assumes certain amounts of stakes on validators, right? But as you go into testnet and stuff, you need to be able to like stake, unstake, that type of stuff. So yeah, minus, and then like RPC stuff, obviously, like getting RPCs like solid so that like people can hammer them when we go.
Well, so since you guys are EVM compatible or equivalent, like what were the hard parts with RPCs?
It's not really hard. It's just like something you got to do, right?
Okay.
RPCs are mostly standardized, like within the EVM. Like there's certain standardized RPC calls. Obviously, our system is a full complete redesign, so how we fetch some of that data from our backend is different than on like Geth or Nethermind or stuff like that. So it's just a matter of like, okay, this RPC is supposed to return these type of receipts. You know, where are we storing them? How do we bubble them up? How do we serve them in a quick enough time? Yeah, and then some like latency testing around like how fast can you query the RPC and stuff like that. Load testing. It's all like DevOps stuff, honestly. Besides the algorithm optimizations, like a lot of it's just like, hey, like the surrounding infra needs to be DevOps to a standard to where, you know, it's good enough. All right.
Yeah, that's fair. In terms of, I'm just curious, like about like more of Monad stuff. Like in terms of applications, like what applications have you seen that are, I'll say, like best suited for this environment that you guys built? Like, or maybe just like what
So
scenarios
obviously the low hanging one is just like high fidelity DeFi. You know, early days in the ecosystem, that was kind of like the main premier use case. Like the amount of interest from that is quite big, large, right? So we have a pretty saturated ecosystem of teams who are committed to coming on board within high fidelity DeFi specifically. Ever since that kind of like reached a certain critical mass, it's been more of like social and gaming. It could also just be like the industry has pivoted to like social fi in gaming too, but we've seen like a lot of interest in different like social and consumer apps in the recent months. And then like a lot of interest in being used as like a brain logic layer for EVMs, which actually makes like a lot of sense. And so for a lot of AI applications or DeFi applications, or even just applications with a bunch of cross-chain liquidity to manage, they look at Monad as like this like quick kind of brain that can like negotiate between all the different EVMs and like do a bunch of computation locally and like send stuff and kind of like be this brain for this like orchestrator system. So we've seen a lot of apps that are using Monad that way. And yeah, that's probably the three main things I'm most exciting about is like there's a couple of sports betting apps that I think that there's like a market for it in Web 2. It's like a demonstrably better like setup for like the bookies and like the people with the fees and the trading and all that, and doing it on Web3 rails versus Web 2 rails. So it feels like this perfect combination of like something with a normie appeal plus like an actual, for the people running the thing, like there's an actual benefit for running it on the blockchain. And so I'm pretty stoked on like sports betting apps.
It's kind of interesting because I feel like it doesn't surprise me that you guys are starting to see a bunch of like consumer and gaming stuff, not only because I feel like that's where a lot of the industry interest has gone, but also because you guys are so kind of like hyped. I mean, you guys have done such a good job like building a community and like building hype around you that like obviously all types of apps that are going to come, even the ones that aren't might not necessarily be like require the exact functionality of Monad, but rather just like, hey, these guys are building like a kick-ass ecosystem. Like I want to be a part of it, kind of thing. So I'm sure you're getting a lot of everything at this point.
Yeah, I think what we've realized is like, you know, the tech is one thing, and it goes a lot of ways, and it gives a lot of confidence to teams. But in today's day and age in blockchains, I think one of the most valuable things you can actually provide to teams is distribution. And that doesn't necessarily just mean like co-marketing, right? Distribution in the sense of like how, like, defining their target audience, like helping them like do that, helping them like figure out how to speak to people in Web3 if they're a Web2 team, if they're a Web2 team, or if they're a Web3 team, how to like target a wider audience outside of Web3. And yeah, like it helps to have a big community that like if a good app comes along, they're just fans of it, right? And so like yeah, I mean like really, I think that's kind of the biggest thing in blockchains right now is like distribution is the hardest thing to get as an application developer. So
Yeah, no, you guys have done an incredible job, probably greasing the wheels for those apps. That makes sense. One thing I wanted to I forgot to ask before actually, and Dimitri, are there areas where this is the open research series, right? So we could just kind of like talk openly about some of these questions that we might have or might be on the horizon as we've done research into parallel execution for the blend environment. As we're taking like the next steps in that direction, are there any kind of open questions that we have like next to research that we might want to like ask Zen about, or what comes to mind like around the corner for us?
Do you mean in terms of parallel execution, of course?
Yeah. No, I just mean like, are there like open questions right now for us that like we're about to research next, or is it just a matter of when we want to prioritize doing it?
So that's a good question because all problems all problems we have are all open problems. Because if you build the platform like blended execution, yes, you literally replace the execution engine. That's it. And you can think, oh, it's so easy. You just need to develop a new VM and replace the execution and blah, 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 and also define all state transitions. So it's quite easy to do. But the next question began, what do you need to integrate into how to wrap your new execution engine? So what type of sequencing do you need to create? What type of rollup? What type of DA? What type of parallel execution? What storage model? What database to use? And these all are open questions, of course, because it is extremely important to make sure that, yes, if you bring the new execution engine, of course, it increases the number of transactions you can execute because the VM is faster compared, for example, to EVM. So will your storage be enough in this case to set all this information? So here I can say that layer 2 is a solution and the rollup is a solution, because with rollups, with ZK technology, you can literally do whatever you want and don't worry about all these distribution risks you have in decentralized world. There is no need for you to worry, for example, about the quality of computation resources across the world, because you just buy 3-5 data centers, you run your dedicated network hardware, computation hardware. I think in the same manner it works like for Monet, where like you just optimize it for specific hardware for specific HEVME storages, for example. So answering on your questions, yes, there are a lot of open questions, and I can start answering on this, but in this case, I think we won't finish this podcast.
I actually have a question that is kind of interesting. How do you guys deal with like the different state representations between different VMs? Do you store them in like with different hash keys, or like how do you end it? Yeah.
Of course, we store them. I mean, we don't store them how to stupidly inside. We do. So we call it. Sometimes we call it account projection. Sometimes we call it execution environment simulation. So we create a set of contracts that project the account state from one type to another type. So I can.
It's like an address translation type thing.
Yes, it's right? Like it is similar to address translation, but For example, if you compare the account model from Solana to Ethereum, you can find that you cannot translate this. Otherwise, you
Yeah,
will
it's
have
like
some
really different. That was my question. Yeah.
yeah. So what we do inside our SDK, we create inside Blend execution, we create a special SDK that specifies the requirements for the execution layer. So right now we're based on Rust Ethereum, and we specify an additional functionality that must be introduced into Rust Ethereum to support blended execution. For example, if you want to have a Solana compatible account and storage model, we cannot store it in the Ethereum tree, of course. So we need to have a separate space where we can store and manage it, and still keep compatibility with EVM and with all these standards we have for different execution environments.
That makes sense. Okay. Yeah. So you just stand them, basically store them in different storage buckets, and then have like an address mapping scheme to look up.
Yeah. So yeah,
one.
just to simplify, we define the set of standards that fits that fit the maximum possible of different VMs and execution environments, and we use these standards to represent all operations in these execution environments. For example, you have storage write operation in Solana, so it is built of different chunks of the chain of chunks. So we have a mechanism to represent Solana storage inside our tree. It is not the same as Solana uses, so it is different. And also we do the same, for example, to manage custom bytecodes. So we simulate like pre-image database using structures that are supported by Ethereum, and also expand its functionality to make it more efficient.
Nice. Awesome. Cool. Yeah. Sorry. I was just curious.
No. Ask away, man. Ask away. Dimitri, are we gonna write our own database?
Oh, why not? Of course.
Why not?
We love writing database.
Yeah. Welcome to
the worst thing you can create in the world is to write, as you mentioned, there's a database, and the second one is to create one more VM. So we violated both these statements.
You're already in it for the pain, so you might as well.
Yeah, we're in the same position.
Fair.
But it is surprising because when you try to figure out what, for example, VM or database to use for your specific task, you find that there is no such VM. So what to do? You have to create something new to fit your requirements. Otherwise, the concept won't work.
Yeah, the most interesting problems, you gotta do stuff from scratch. So.
Yeah, a variety of interests.
Cool. Yeah.
All right. So, for these episodes, we end up doing a rapid fire round to finish them off, a little yes/no questionnaire. And I figured maybe we can just end off on that note. I know you've been generous a few times. Then don't want to keep you too much longer, but maybe we can go through five or six of these. Is that cool, you guys?
Yeah.
All right. Okay. So, yes/no questions. Remember, should Ethereum implement parallel execution?
No.
Should or will?
Should.
For sure.
Should. I think it should. I don't think it will. So.
We're gonna go off the.
I think they shouldn't, and I think they won't.
What? Okay, Zen. Why should they? And what's like a reasonable timeline to actually do it?
So I think they should, because I think it'll make I don't think they should unless they do a lot of other things, right? But if they went down the path of making the L1 parallel, I do think it would change the roadmap for Ethereum out of the scope of what they're trying to be. And so that's the hardest thing. Like Verkle trees are very hard to parallelize. And like they're kind of wanting to be a settlement layer. And there's just like, if you go down the path of making it, like I'm kind of in the Max Resnick camp. Like I think the L1 should be more usable, and so I think they should do stuff to make it more usable, right? But that also is kind of counter to the rollup centric roadmap as being like this state verification layer in certain ways. So do I think they will? Probably not, because like for their stated roadmap and objective, it's probably like not the best thing. But I am a little bit more in the Max Resnick camp, where I think like they should improve the L1 usability for users, but there's a lot of implications there. Yeah.
What's the common thread there? So you got like on one side people probably being a little bit too strict on like don't almost like don't make the L1 performant, we're a settlement layer, but then also I can imagine people kind of taking it too far the other direction, just as the pendulum often shifts to like, oh wow, you know, we can't compete, we don't want to like shift the roadmap towards competing with like Monad, Solana. What's like what are like the main things you think that Ethereum L1 can do from an execution standpoint that would kind of satisfy both? Like, what's the common denominator? It's like, oh, just fast finality and something else. Like, what? How do you think about that?
I mean, you don't have to make the L1 parallel to make it fast. So that's probably where, like, you could probably start. It's like, just like, yeah, I think EOF's a great step. I'm actually like very excited for it. Like that's definitely an improvement that I would like to see on the EVM. I think you could still make it a fast L1, even if it's not parallel. It's probably good enough for the set of things that they want to use the L1 for. But yeah, honestly, I'd be curious to hear Dimitri's take on why he doesn't think they should go parallel.
Yeah, I have several answers on this, and all these answers, all these answers say no. So my first no is because of Ethereum philosophy, and here I means not the overall philosophy of Ethereum, but the way how they position themselves for developers, and they try to avoid any overcomplicated things to happen. And the problem I highlighted before, if they go with, for example, strict parallelization with non-optimistic parallelization, it can bring additional non-obvious scenarios for developers where they don't expect from platform to do. And Ethereum is designed to be very simple, very understandable, and very adoptable for developers. So I think to keep the maximum compatibility with developer expectations, that's the first answer. And I put it in the same as Ethereum philosophy. And the second, of course, it's also the part of Ethereum philosophy is decentralization, because if you bring parallel execution, so you cannot just parallel transactions, it won't work. You need to find several optimization techniques to achieve this, and the easiest optimization technique is to optimize hardware. So it strictly goes against all the recent article is published by Vitalik about the distribution of Ethereum problem and the problem of the consensus layer. So the goal of Ethereum to have the maximum decentralized distributed execution network. It is not, the execution is not the bottleneck right now, and they are trying to optimize not the performance of the network. We have layer 2 for this, and we can scale the network using ZK, using rollup technology, using optimistic technology, but to optimize the quality of the chain. So to have a single sustainable platform that is fully resistant to any potential attacks and as scalable as by having all these like layer 2 solutions, for example. That's why
I think this is. Yeah, I think this is like right at the core of the Max Resnick type debate thing. Is like, at least your second answer there is that like I just actually think they should raise hardware requirements slightly, which is exactly what Dimitri said. Is they would have to do it, which might just change like literally the philosophy of what Ethereum, like the optimization function of what Ethereum is used for. So do I think they will do it? Probably not. Like obviously I come from Solana and I went to Monad, so like my philosophy is much more aligned in the like let's increase the box size a little bit and like and make the L1 more usable. So yeah.
They 100% won't be as parallel, for example, as Solana, and partially can agree with you because they started to bring several features and they start to enable a lot of community-driven functionality like native account abstraction, EOF files that are technically are not super required. It expands the instruction set, it makes the system more complicated, but it makes developer experience much better, and developers can build better apps using this technology. So maybe the best answer here, if parallel execution makes a developer's life better, then they should integrate this. But I'm a bit skeptical here.
Yeah, I actually would agree. I think it makes developers' lives more complicated, generally speaking, to deal with parallelism. So yeah.
How would you, speaking of the block size thing and like, you know, making like the Max Resnick kind of camp, how would you think about what is the optimal point for like Ethereum L1? Like, how should somebody think about that? Like, clearly the reason why some of these heuristics develop with like Bitcoin, like, you know, block size and stuff like that, because it's just an easy way to think about things. I'm not saying it's right or wrong, but like, you know, Ethereum, you know, they want to be on consumer grade hardware, like, it's definitely just like an easy way to think about it, but like what's in your mind a better way to think about it given the greater performance it should have?
I mean, well, I'm like super biased because like I'm at Monad because I think it's the right optimization point, right?
Yeah, fair.
Like, but at the same time, like I don't want Ethereum to become into Monad. Like, I don't want Monad to become Ethereum, right? And so, like, obviously, if I was like able to pick an optimization point, I would pick like the Monad.
Become
point.
Monad, yeah.
Yeah, but I don't think that's the right answer for Ethereum. Like, so, yeah.
Yeah, fair enough. I guess it just mean like knowing what their goals are to be able to still achieve the goals with like higher throughput. But yeah,
I think they could raise bandwidth to like 100 megabits per second. I don't think that's unreasonable. That's kind of the main bottleneck. They still wouldn't have to address like parallel execution or anything like that. They could get a lot of the benefits just from increased bandwidth and lower block times. And so at the very least, I would. Yeah, at the very least, I would like aim for single slot finality, lower block times, increased bandwidth, and like the multi-proposer stuff. I think is super valuable.
Seems super reasonable, honestly. Okay, so how about what's the next one? All right, will parallel execution become an industry standard at L2 within the next couple of years? Will everybody basically have to do it to compete?
I think, honestly, parallel execution is an interesting one in the context of blockchains because the reality is like the fee markets, right? It's a weird environment where you have fee markets, right? It's like the only execution environment where you actually like pay in real money to keep the executors going, right? This is like why we have gas, right? It's one to incentivize the network, other thing to charge for compute, and like, you know, a side effect of that is that you don't have like infinite loops, right? Like on a normal computer, infinite loop doesn't matter, whatever, computer processor's busy. On a blockchain, it has this like, it actually like slows down the entire blockchain, which points at something that I'm trying to get at is that like block space is fundamentally limited, right? And so like, even in a parallel environment, when you get to the point where your entire block is full, you actually have to price it as a global environment. Okay. And so there's this weird dichotomy where like, even if you can execute everything in parallel, you're still limited in actual like total compute. And if your blocks are full anyways, in some scenarios, it's probably actually just as efficient to execute everything in serial. It depends on like what state it testers and stuff. And so like, I do actually think there's a weird world where if you like, you could see some single threaded environments survive, generally just because like if their block sizes are limited enough to where it's always a saturated market anyways, and they have to like serialize it, then what does it matter? At that point, you could kind of just, you know, if you're fast enough to execute some amount of gigagas and no one cares, then like sure, I guess you could be single threaded, right? But I do think the general consensus is that most things will move to a parallel execution environment. Like if you had really small blocks that are always saturated and are moving like very, very quickly, like imagine like a blockchain that produces blocks like every 10 milliseconds and it's like probabilistic as to what's going into each of these and they're tiny blocks. Like, I don't know, this is a weird construction that I've never seen before. But like I do think there's some weird construction there where you actually wouldn't want parallel execution. But yeah, I think for the most part it will be industry standard. Yeah.
Dimitri, what do you think?
I think the question is not correct because if you want me to answer on this question, I'd say no, it won't be the standard because I think maybe humanity misunderstand the meaning of the layer 2 words, but I don't see a chain as a part of, or some execution platform as a part of layer 2, because layer 2 can be anything you can settle. And if you want to do a time lock puzzle, so it's impossible to create to do a parallel execution of time lock puzzle. That's the nature of time lock puzzles. And the same, so you can create any app. For example, if you do like exchange execution, you execute trades. So you have to execute them sequentially. You cannot parallel the execution of trades. Otherwise, nobody knows what can happen. So I think that's the problem. So I can say yes and no, because it will be the industry standard where it's needed. Where it's not needed, it won't. So quite obvious and simple answer.
Yeah, I actually think that's a good way to frame it. It's like, I think like in general execution environments where you want everything to go on in a single execution environment, yeah, it's probably going to be standard. In application specific execution environments or very specific ones, it's probably not.
Yeah, if it's not going to benefit those, then why bother doing it? It makes sense.
Yeah.
Okay. Is 100K TPS real?
Yes.
On
my computer.
Yeah, it's like, is 100. When you're saying TPS, do you mean fully verified settled transaction, or can I listen to 100K on a WebSocket? Like that's the question. To me is like
I can listen. I can even put some assumptions on this. Of course, it will never be decentralized, maybe, but yes, the question is to question the question. What assumptions do we have? So it's not technically strict. I can answer yes and no, and both answers are correct, because if I say yes, because yeah, I can run 1 million TPS, I can run 10 million TPS on my computer with zero assumptions for all of you, and say, oh, guys, I calculate your transactions on my computer. Do you want to get proof? And but for ZK, it's possible, because you can give me your money. I can calculate 1 million TPS on my computer. I will spend years on calculating this, but it's 1 million TPS, why not? And then I can give you the proof that proves the correctness of all these computations. So I have 1 million TPS. The settlement is can take like years. Why not? Because calculation of the proof is expensive. But I can do this. So technically, I have 100K TPS or 1 million TPS.
Just put the former on your website, not the latter. Just see that easy. Okay, yeah. So I honestly, I wanted to find, I'm glad you guys laughed. I want to find one that was especially hard to answer yes or no. All right, there's a couple.
That one's
couple
just weird, because like, how do you define a transaction? When's the
yeah.
Like for me,
there's
like the usefulness of a transaction is only after it's been verified, which means it has to go through consensus, which means you're limited by the speed of light, which means like, yes, maybe we can get to 100K or 1 million transactions if you're talking transfers. But then also, like, does that mean creating your own internet, like the darknet thing that FireDancer is trying to create? Like, so like, you know, like, is it possible? Yes. Like the technological list and the caveats around like how that would happen, I think is like incredibly important. It's like, yeah.
All right. Should Monad be considered an alt VM?
I mean, in its final form, I would wish it was, quite frankly.
Really blended.
In the sense of like, not to say like, I honestly want it to be looked at, but this is like my own personal opinion, is like EVM plus plus, in the sense of like C to C plus plus, right? To where like it's a superset of the EVM. Like that's ideally what I would like it to be, in its final form. That's my personal opinion. Right now, I think it's still like it's an alt L1. I think it's a normal EVM like VM, not an alt VM. So
Dimitri, what do you think?
I think Fluent should go LTM.
It was definitely an all VM. No, I clearly people bastardize VM versus execution environment. So I mean, like it's just.
So can you elaborate what do you mean by this question? Because we can take Monet and replace the execution engine, and it still means that Monet goes alt VM, does alt VM. But but it is wrapped into Fluent, yes. So technically, okay, my answer is yes.
All VM questions are trick questions. Because what's a VM? Okay.
Tricky question.
Last question, last and final question. Will Mana become an Ethereum L2?
I don't think so. But like that's not to say that I don't think at some point you won't see an L2 with Monad's execution code in it. Right? So like, yeah, I think we're just like optimizing for the L1 problem. Like that's where the expertise is on the engineering team. That's the problem we're trying to solve. Like it's a different constraint set. Do we think like L2s will exist on Monad? Yes, of course. Will they probably like fork the Monad code base to become an L2 on Monad, just like, you know, EVMs fork the Geth code base? Probably, right? So in that sense, like, will Monad become an L2? Yeah, you'll probably see like an L2 with the Monad execution environment on it at some point. But like Monad as it exists today is not currently flirting with becoming an L2.
You concur, Dimitri?
I can answer for Monet. Yeah. I thought Monet is layer 2 for Ethereum, but oh my god, it's not. So
it's not. We're not. We're one of those alt VMs, those dirty alt L1s. So yeah.
Oh man. All right. Well, thank you guys.
I actually don't think it's gonna matter. Oh, wait. I gotta put a final point on that. I actually don't think it's gonna matter if you're an L1 or an L2 in a couple of years. I think the end state really is ZK. Like I do agree with that thesis, and I think we'll just pass ZK state roots between each other at some point. And for some execution environments, they'll pass it to the L1. For some L1s, they'll just pass it to the execution environment that cares about their state. So.
Okay, you just wait until we solve the problem. Yes. Okay.
Yeah.
All right. Any last minute comments there, Dimitri? Anything else? Did we ask everything we wanted to ask him?
I don't have questions.
All right. Well, thank you both for entertaining me. Thank you, everybody who's still watching. And yeah, thank you, Zen. Appreciate you coming on. Always a blast. And yeah, maybe well, I'm sure we'll have you on again at some point.
Awesome. Yeah, it's always fun. Have a good one, guys.
All right, see you.